Hello world, and welcome to Beamstream. This is episode 2 of the REST API Frameworks review. This time we'll be covering Kotlin and Spring. This is probably one of the most popular technology stack within the Java ecosystem. Having said that, obviously I'm using Kotlin to kind of use the language, but the framework used is going to be Spring Boot. Spring Boot is probably one of the most popular frameworks out there when it comes to distributed systems that we make today. So just to give an overview of the Kotlin or the Spring ecosystem today and what makes them tick. Just to give an overview, and this is going to be quite hard since Spring Boot framework is actually quite a large framework and it encompasses a lot of concepts, but I've tried to kind of make this as easy as possible. So Spring Boot in general, because of the nature of the language, which is Java, it takes a more object-oriented approach to designing and architecting distributed systems today. It uses the Java annotations feature quite heavily to kind of separate the concerns. So how these concerns are separated is from the use of stereotypes. In Spring Boot, you have a series of stereotypes. Now, when it comes to Spring Boot stereotypes, all of the major concerns are separated through this hierarchical labeling of a piece of logic. So in this case, when we declare, for example, a component annotation within a class in Java, you would basically kind of give a responsibility to a class. Now, it's the developer's responsibility to mark certain things as a component or as a service, repository, controller, or configuration. Briefly go over all of them. A service is essentially a class with business logic, and that's it. It's only concerned about the business logic. It has no concerns over the database connection, over the repository calls, and it's not an entry point for a REST API to come in, right? A repository is everything to do with persistence. So in this case, it would be a database. Now, the controller is what brings in both the service and repository. A configuration is something that's not quite touching any of those components, and instead it's a configuration to change something. So for example, if I want to change the way I handle Json validation from a request, a configuration might be the appropriate stereotype to use. So this is Spring Boot in a nutshell. It's using a series of classes where you can declare them by a stereotype. And by declaring them by a stereotype, we have the separation of concerns. And that is essentially Spring Boot in a nutshell to create distributed systems. Now we've kind of dealt with the typical things that you'd expect from a Java app, or rather a Spring Boot app. It's important to know how everything works in practice, right? So I've created a very simple application that deals with very basic queries of a database. And in this case, the database that I will use for projects for other technology stacks across the board will be MongoDB. So MongoDB is just a database that I've chosen. There's no particular reason why. I just wanted to have a flow end-to-end working with the web framework. So in this case, everything starts off with this run application method where we're able to kind of configure everything and it runs the entire application. This is the entry point really to starting the application. So as you can see from line 8 to 11, there are a bunch of @signs. These @signs are essentially what is called the Java annotations, right? This is what we label to give responsibility, to give logic without any bloat that we see in Java typically. So in this case, to start an application, you need to label something as a Spring Boot application. In order to get database connections working, we need to say enable Mongo repositories. And of course, in order to auto-discover configuration files, we need a stereotype enable auto configuration. So in this case, I will start off from how do we get a request coming in from an outside world into our app. Everything begins and finishes in the controller, typically speaking, or rather simply speaking. In this case, a controller is everything to do with the entry point of an endpoint, right? So right now I have a very, very simple and trivial task API where a user can create a task and retrieve a task. So there's a lot to cover, but essentially, first thing you'll notice is the stereotypes involved with them. So REST controller is essentially a branch of the controller stereotype that I introduced. Request mapping refers to the actual endpoint that a user needs to point to, right? But at this point, request mapping is like the parent mapping, where a person actually makes a request is from the functions, and in the functions you can declare the entry points. In this case, the get mapping, without any sort of argument passed in, will allow a user to do a GET request straight away from this API. If I had, for example, a / passed in, they can only do a GET request when there's /API /tasks /, and only then a request will be registered. Now, when it comes to parameters, the URL parameters, and how the framework deals with that, you pass in curly braces the variable that you want. In addition to that, you can pass in the actual parameter in the function itself. In this case, we actually want to make additional validations. And what this means is, as well as allowing an ID to be passed in from a /, you should also validate that it's not null, and that we're also saying that it's a path variable, not a query parameter variable. So that's what Spring, how it ties everything together from requests, right? So to kind of move on, in terms of how the code is structured and how we architect this, a few things to note would be, because this app is really so simple, there is no service, right? Because at the moment there is no business logic. At the moment the app is so trivial that all I actually want to do is to return the results from what you would get from a database. Let's just go with line 27, where we deal with getting a task, right? So starting from the start, we have a task repository. A task repository allows us to do database calls. And if we go into this task repository, quite interestingly, everything, well, not everything, but this is actually an interface that extends off a Mongo repository. Now, because it's an interface, you might be thinking, but nothing is implemented. How does Spring Boot know what methods are available and how is it implemented? Well, this is the nature of Spring Boot. It has a lot of assumptions about what we would want in our queries, right? And quite interestingly enough, obviously you need to have the correct stereotype. This is a repository because this allows database connection, and it's a persistent connection throughout the application, right? So if we go back, first of all, we can see that the task repository is coming in through the constructor. Now, this is another Spring Boot magic where we allow something called dependency injection. I won't go into too much detail, but all you need to know is when we pass something in a constructor that's a class, Spring Boot will automatically detect and allow this because almost all of the classes are singletons, right? They create at least one instance of itself, unless you explicitly tell it not to. So because of that, it allows us to do easy dependency injection. So having said that, from the way that it's called, we have a method called findById. Now, how does it know that we have a method called findById? It's because of the actual model that we pass in. So in this case, the model that we have is quite simple. We have a name and we have done. We have the name of the task and if the task is done or not. The ID is optional because, well, in the Mongo world, when we actually, insert it into the database, it will generate an ID for us. It doesn't actually need it for when we need to make a request. So that is one thing. Don't worry too much about these additional sort of annotations. These annotations are essentially field validations that will help the REST API to handle errors, right? This will come later on. And for every entity, at least in the Mongo world, we use document to signify a data model for our database. So that is another thing. So having said all that, it knows to it knows to have a method called findById because we actually have the model with an ID, right? We allow them to get a task from a path variable where we call findById. And if it was Java world, we'd have to do very long syntaxes to check the logic to say that, if a task actually exists, then retrieve it. Otherwise, return an exception. But it's just a more simplified way in Kotlin without the bloat. So because we know that at least in this case, when we try to find a task, it returns an optional task. What this means is that it could return something, but it could return also nothing, and we have to handle that. If it returns something, then we simply get it, and then we give the status code. So that's another thing. We have this response entity class, which allows us to make very easy responses with a response code. When it comes to errors, it's slightly different based on what you want. If we want to throw a body with a status code, we can throw a response entity with the body and then the status code. But in this case, when something isn't found, we simply return a not found status. Now, moving on to the post request and how we want to deal with that. Again, we're not passing in anything to post request or to the post mapping. This would mean that users are allowed to do post requests straight from this API, or rather this endpoint. So that means that for both GET and for post requests, you can do requests on this endpoint. So the post request is actually quite simple because all of the validations are declared already from the data models, which you've seen previously. So when it comes to creating a task, it's actually quite simple. We say that from our repository, we simply save the request coming in, which is a task. Now you can see additional stereotypes or additional annotations rather, where we say that the task coming in is a JSON body. As well as that, we check for the validity of the JSON body too. Now, if we assume that everything is okay, we save it into the database with the correct status code called created, or rather 201, I think is the status code. So that is pretty much it. That is most of the API. Now, where things get interesting is actually handling the edge cases of JSON parsing. At the moment, there is a lot of implicit behavior within Spring Boot. For example, if a data type coming in that is incorrect, but it's able to be converted, it will convert it. For example, if the name was 1234, the task name, and we tried requesting that, Spring Boot will happily accept it, except in the backend, Spring Boot will actually coerce the data type. It will convert the data type as a string, 1234. Now, it's also the same thing with Booleans. Booleans, if a string named false was passed in for done, it will actually coerce that data type from a string to a Boolean. Now, whether this is behavior that you want, it's already there out of the box. However, if it was a public API and you kind of wanted to communicate that the way the data type they're passing is incorrect, this behavior actually needs to be overridden. So as a result of that, I've written a configuration where I use a stereotype configuration and I override certain behaviors of the object mapper, which is responsible for JSON parsing. So yeah, this was another thing that was an interesting find within Spring Boot. So moving on now, the interesting thing with error handling within the Spring Boot ecosystem is that there's so many ways to handle it. In my case, I've encompassed all of the error types within one class, and that's why we have a stereotype named controller advice. This controller advice extends off a handler exception resolver, and each function is basically handling a certain exception class. So this is my way of handling all of the potential errors. In terms of conventions of how I want to return errors, if a field is invalid, so if it's an invalid type, it will have the field name underscore required as the error code. If something is completely just not there, so if a data type is null or it's completely empty, the error code to return here would be the field name followed by required. So in order to have all of that logic handled, I've decided to have an error class kind of encompass all of those cases. So moving on, why do we need so many sort of exception handlers encompassing several different Java classes? Well, sometimes the validation errors can come from different points in time. Sometimes the error that is given, or rather the request that's given, is able to handle the error before it goes over any of the other exception handlers or the exception classes. So for example, if Spring Boot can handle model validation before it gets to a Kotlin parameter exception, it will handle the error from that point, which is kind of confusing, but this is what I found that worked. And so, but once you found all of the exception handlers that it does touch, it was easy enough to handle any sort of particular errors. That was one thing that I found interesting with error handling. Now, in the same light of handling field exceptions, so when it doesn't match the data model that we expect, I wanted to also additionally handle any of the other misuse of an API. In this case, if the data type says that it's JSON, but it's completely invalid, we want to return a JSON_invalid error code. So this was also handled using the JSON parse exception class. In addition to that, I think for not found cases, I want everything that's not found to simply return the status code not found without any. That's how I've decided for the API to handle errors. So moving on, there was another piece that I wanted, which was to be able to handle creating request IDs, right? Because in a distributed world, I want to be able to capture the entire flow of a request. So what does this actually mean? It means I actually want something called a request ID attribute. Now, this request ID actually needed to be handled for, and I wanted a request ID to be generated every time a request came in, whether they were errors or not. And I'd have to play around with the entire life cycle of understanding Spring. But essentially, I finally found the life cycle that I actually cared about within Spring Boot, which is to extend a filter class where a filter will be run on every request that a Java Spring Boot app can return. So in this case, having found that out, finally, that took a while by the way, I was now able to add request IDs in a Spring Boot app. So that is pretty much the application. Going on to the actual testing, a few things to note. When it comes to running tests, there is the implementation package, which is quite typically named main, and then a test package, where you can test for whatever you care about. Now, the tests, I will just go over the controller tests, because this is where we make a semi-real test with some mocking. Now, please ignore the late var sort of declarations. This is a more Kotlin concept, but essentially, I wanted to be able to mock the database entry that we want, and as well as that, I wanted to mock the Mongo connection as well. So the next step was then being able to actually test that the logic works as intended. So this is the kind of good middle ground that I wanted when it comes to testing. It's, if I wanted something to be mocked, I can mock it. And if not, I don't have to mock it. But in this case, I've opted for mocking the repository layer. In a more real test, I would call them end-to-end tests. But for the sake of a small example, it would actually fall under integration tests or unit tests. So implementing the integration tests was simple enough once I got to know how everything was actually wired together and learning all of the Java Java conventions to testing, right? But after I've learned all of those things, it was quite easy to get things working in terms of how to request for my API. And in this case, it would be through the use of MVC. This MVC is a mock MVC, which actually connects to the Spring Boot instance, where you can perform requests on the actual application. It's just that the repository side of things is mocked. So these were relatively easy to implement, and it was quite nice that actually we correspond all of the implementation files with a test suffix, though I guess it comes down to like a namespace conflict where it kind of conflicts if you have similar names in the test package. So maybe that's why we have to suffix a test, a test suffix. So yeah, that is the application in a nutshell. So moving on to the test suite and the kind of external testing that I wanted to do on the API are a series of edge cases that I previously talked about. We're talking about JSON validation, how I want errors to be handled, and the format of error codes that I actually want. So let me show an example of how the app is currently. So when we create a task, we can create them quite easily, right? But then let's say something isn't looking quite correct. For example, done is equals to null. I want it to say that if done rather doesn't exist, it should return required, well, the field plus required. And similarly, if the field is completely blanked, it should again validate for that case as well. And it should also validate the data type coming in. So if it's invalid, we say the field name followed by invalid. In addition to that, we also say that we actually want to validate for this, right? Where we validate for extra fields. So when we make that request, it should give us again a validation error. So that is how I want the API to be valid, or rather to behave. And I've run a series of tests and it works completely fine. 404 test should also additionally return 404, where we try to get a task that doesn't exist, for example. It should just give us 404 without any body, and it works as intended. So the second, or rather the last part of this is, I guess, is quite fun. It's just a fun experiment. It's a very trivial API, so don't expect anything to be too slow, but we can gradually make comparisons across other technology stacks. So how I'm going to run the Java application, let me stop this. So how we run the actual Java application is we run a built instance and we limit the CPU usage to only use 2 cores, right? Because I'm a cheap guy, and when it comes to creating these applications, I want to be able to deploy them in a very small box to start off with. So let's run this. So at the moment, I'm just packaging up the jar file, and then we should be able to run it. So now that that's running, I can then run the performance tests. And I'll see you in 2 minutes. So I've run the performance tests, and if you're curious enough to know, I use a framework, a Rust framework called Goose, where it kind of, it's essentially a performance load test framework implemented in Rust, and I just wanted to try it out. So for the fun of it, you can see the results that we get. We get, for example, from the tasks metric, we have create tasks as well as get tasks. You can see how many tasks ran per second and how many failed, which thankfully was none. So the latency as well, the average latency was very low. I mean, it's expected because it's such a trivial app. So yeah, that is Spring Boot in a nutshell. It's kind of a very simple layout of how, you would do a Java app. Well, in this case, it's Kotlin because I found Kotlin easier. To conclude, Kotlin and Spring Boot, in this case, provides a very easy implicit way to get REST APIs working. In terms of the actual points to talk about, the request response was relatively simple to understand. Through the use of routing and additional query parameter or path parameter handling that was already quite declarative, right? In this case, for JSON handling, JSON parsing, that was all implicitly out of the box as a feature for using Spring Boot. So it was also able to handle, model validation off the bat as well. It's just that when it came to actually designing validation response codes or error codes for that, that's where things kind of took a bit of complexity. But it was good to know that I could override behavior that's default from using classes, right? And that was probably the main thing. Though if you want implicit behavior where, data types are converted or coerced to the appropriate data type, then that's already there out of the box. It's able to handle invalid JSON should you want to keep to the original error message that you get from a Spring Boot app. When it comes to testing, it's good to know that at least the implementation and the tests are all completely separated in different packages. I guess the mindset here is a separation of concerns which they haven't broken completely. It was also good to know to have the flexibility to mock whatever you'd like in a Java app, whether that's the database layer, so the repositories, that's easily mocked using JUnit. That's the testing library for it. So testing didn't come at a quite costly learning curve, especially when you're kind of well versed in object-oriented programming. So that is my final conclusion to using Spring Boot. I would say, even though some people think that it's a dying language, certainly that may or may not be true. It's hard to say, but there is a reason why, for example, big financial companies are still using Java today. There's a reason why Spring Boot is still used today as well. The speed of development sometimes far outweighs the performance costs, right? And where performance isn't completely the first-hand requirement, it's still able to run performant in a performant way. With 20 years of baggage comes 20 years of well-versed veteran-level experience that you find online as a resource. So that's also something to keep in mind. And with that, I will conclude with asking, what are your thoughts on Spring Boot? And would you use this as part of your technology stack?